This lesson focuses on properties of logarithms, and this will be part one. And in part one, we're going to look at the base change formula for logarithms, and we're going to look at the basic rules for properties of logarithms. And in part two, we'll expand these properties more and discuss those. Okay, so if you look at your calculator, so if you take your calculator out and if you look at it, you'll notice that your calculator has the log function right here, log. Now remember when you if you look at this example number one and you press log right here, and you say I'm going to take the log of 8, and you do that, and then let's just close the parentheses here, and you press equal, and you get this, right? Okay, so that's approximately equal to, let's go ahead and use 4 decimal places, so 0.9031, okay? And so basically when you did that, you'll notice that there was no base right here, right? So that was base 10. So remember, this right here is base 10, all right? And if you look at the other example, if you take ln right here, and you press ln, okay, so you say ln of, let's say, 8 again. All right, and you do approximation. Let's do 4 decimal places. And you notice that you get 2.0794 to 2 decimal places. So 2.0794. Remember, this is base E. Okay, so and you see no other logs on this calculator. So almost all calculators have only 2 types of log keys. Okay, 2 types. One is the common logarithm. So remember, this is called the common logarithm. So that's called the common logarithm. And then base E is called the natural logarithm. All right, so your calculator uses 2 bases of logarithms. Base 10, so that's common logarithm, that's the log button. And then base E, which is a natural logarithm, so that's the ln button. Okay? So it's very easy to, if you're given the log of 8 or the log of natural log of 8 or the log of, let's say, 0.6, and remember, if there's no base listed, you're looking at the common logarithm, so base 10. So if I take the log of 0.6, you'll notice I get a negative 0.2218. Okay? So negative 0.2218. All right, now, what if though? What if you have something like this? What if I want to take the log of 7 base 3, right? Okay, so I know that the calculator can evaluate a log, a common logarithm, and a natural logarithm. So the calculator can evaluate a common logarithm and a natural logarithm. But how do I use a calculator for something like this? How do I use this? Because in a previous lesson, remember in a previous lesson we had something like this. I'm going to go ahead and do that here. So let's kind of review this. In a previous lesson, we had something like this. We had log of 8 base 2, right? And again, I'm evaluating this, but in a previous lesson, I did not have to use my calculator on this. Because remember how we did this? We said equal box, and then we said we converted this log equation to an exponential. So we said 2 to the box is equal to 8. So 2 to what power is 8? We said 3, right? So the box would equal 3. So 3 goes here. But that's not that simple here, because look, if I convert this just like I did this, if I do this just like this, I want you to think about this. Log of 7 base 3 equals box. 3 to what power is 7? There is no nice number. I mean, there is a real number that works, but it's not a nice number like this, like this whole number that we did here. 3 to the second, 3 to the third, 3 to the fourth, that's never equal to 7. Okay, so that's never equal to 7. So we still want to approximate possibly what this is, because sometimes you may want to graph a function that has base 3. You may want to do other things with a log function that has base 3. But for most purposes, though, and most, if when you take your science classes or other math classes, your logarithms will usually, the most common logarithm is a common logarithm or a natural logarithm. Okay, but once in a while you'll have to deal with base 3 or some other base other than 10 or e. Okay, so let's talk about this though. So there is something called a base change formula. All right, so a base change formula. All right, so listen to this carefully. So your base change formula. All right, base change formula. Okay, and we're going to use it with this as well to show you that this base change formula does work. All right, so base change formula. So if you have the log of x with some base a, okay, log of x base a. What you want to do, remember you want to use your calculator, correct? Well, what logarithms does your calculator use? Your calculator uses base 10 or base e, right? So it uses a common logarithm or a natural logarithm. So if you want to be able to use your calculator, then you want to change this to either a common logarithm or a natural logarithm. Now here's what the base change formula says though. All right, so you're going to say that's going to equal the log. Now remember, you want to change this to a new base. You want to change this to a different base. So the base change formula says I can take any base and change it to another base. So what's going to happen is there's going to be an infinite number of possibilities here. So again, I can change, base change formula says I can change this base to any other base. Okay? You can change this base to any other base, and here's what you do. So you're going to say in the numerator, this becomes the log of x. Okay, now listen carefully. Log of x divided by the log of a. Do that first. Okay, so what I would do is I would rewrite this as the log of x divided by the log of a. Okay, now let's talk about the new base. And you can use any new base you want. Any new base you want. Okay? So if I look at log of 3 base 7, log of 7 base 3, then based on that, log of 7 base 3, then what that means is that I can write this as the log of 7 divided by the log of 3, no matter what my base is. I can put a 2 here. I can put log of 7 divided by log of 3. I can say base 4, right? Log of 7 divided by log of 3, log of 5, and so on, right? Okay? So any base. But which ones does your calculator use, though? What base does your calculator use? Well, your calculator uses base 10 or base e. So I can do this also. I can say, all right, I'm going to convert that to base 10 then. So I can write this as log of 7 divided by the log of 3. All right, that's fine. What base do I use? That is base 10. I could say, all right, I'm going to convert that to the natural log, so base e. But remember, we prefer to write ln for base e. So natural log of 7 divided by the natural log of 3. All right, let's use a calculator on this one. Because remember, I can use a calculator here because your calculator uses base 10 or base e. So if I do this, let's look at this. Log of 7, log of 7, log of 7, don't forget to close the parentheses, divided by log of 3, close the parentheses, press equal, and that's what that equals to. So 0.4032, approximate to 4 decimal places. So that's approximately equal to 0.4032. Now, what that means is that, see this right here? That's equal to all these. So all of these, and there are an infinite number of those, by the way. I can continue on with all these bases. But remember, your calculator only uses base 10 or base e. Let's see if that's the same thing. According to this, it better be, right? So let's see. Natural log of 7 divided by the natural log of 3. Press equal. Oops, I did the wrong thing, didn't I? So let's do this again. So natural log of 7 divided by natural log of 3 equal. All right, so so this says that, so I may have done something wrong here. So let's go back over here. Log of 7 divided by log of 3. All right, so yeah, I did something wrong here. Sorry about that. So I'm not sure what happened previously. So this is 1.7712, and we saw a while ago this is also 1.7712. Okay, so I'm not sure what happened. I may have put something in calculator and I didn't see it incorrectly. All right, but that's what this is. Okay. All right, now let's go back here and see if it works here. So let's use a calculator with this. All right, let's use a calculator. So we have the log of 8 base 2. Let's use the base change formula. According to the base change formula, I can change this base to any base I want to. Does not matter. But since I'm using a calculator, let's use base 10 or base e. All right, so I'm just going to go ahead and use base 10. So I'm going to say log of 8 divided by, and what do I say? Log of 2, right? Okay, so the argument goes in the numerator, the base goes in the denominator, just like that. Now use a calculator. Hopefully we'll get, what should we get? We should get 3, right? All right, so let's see what we get. So the log of 8 divided by log of 2, right? 2 equal, and you get 3, okay? So that's equal to 3. I could also have done the natural log. Natural log of 8 divided by the natural log of 2. Let's see what we get there. Natural log of 8 divided by natural log of 2. And you get 3. Okay? All right, so the base change formula, that's the base change formula. Okay? So what I need to remember is this. So you have to know the base change formula. You have to know the base change formula, and you have to know how to use it. All right, so base change formula. Let's kind of talk about that again. All right, so if you have the log of x base a, I can change that to any base I want. So let's say I want to change it to base b. So that's going to be the log. What goes in the numerator? The log of which of these? Log of x. And the denominator is the log, and you put the base here. And then you're going to, whatever base you want, as long as it's a logarithmic base, okay? So remember, you can't have 1 or a negative value for your base. If you want to change it to base 10, which is what your calculator uses, then you say log of x base a, then would be just the log of x divided by the log of a, right? If you want to change it to base e, then the log of x base a would be the natural log of x divided by the natural log of a. Okay? All right, so that's your base change formula. It's very easy to use because your calculator uses base 10 or base e. Okay, let's do one more with this. So let's suppose I had this. All right, so this will be, let's call this, so this was number 4, right? Okay, and we saw number 4, the answer was here. So this is number 4, right here. All right, number 5, let's suppose we had the log of 25 base 4. Log of 25 base 4. All right, so remember, you're using your calculator, so it does not matter whether you use base 10 or base e. So that's going to be the log of 25 divided by the log of 4. All right, and then use your calculator. Log 25 divided by log 4 equal, so that's approximately equal to 2.3219. Okay. All right, and then let's look at number 6. So let's say number 6 is this. So let's say this is number 6. So we have the log of 19. And then let's say the base is 0.2. Okay, log of 19, and the base is 0.2. All right, well, so remember, your base doesn't always have to be whole numbers, right? So remember a while ago when I did this, I use base 2, base 3, base 4, base 10, base e, and so on. I mean, I could have said this is also equal to log of 7 base 3. I could have also said that's going to equal log of 7 divided by log of 3, let's say base 1.6. So your bases can be positive decimals as well, right? Or so your base can be rational numbers, your base can be irrational numbers. It's just that your base cannot be negative or your base cannot be 1. Okay, so remember we did that in previous lesson. Okay, so this will become the log of 19 divided by the log of 0.2. Or if you want to, you could have said the natural log of 19 divided by the natural log of 0.2. Does not matter. You'll get the same answer. So let's see what this is approximately equal to. So the log, let's do the natural log. Natural log of 19 divided by the natural log of 0.2, right? And that's negative 1.8295. Negative 1.8295. So make sure you round off to the nearest thousandth. Okay? All right, so that's the base change formula. Okay? All right, now let's talk about properties of logarithms now. Okay, properties of logarithms. And these are going to be the basic rules. Now, in a previous lesson, you learned about other properties of logarithms. Okay, we did do that. We learned about other properties of logarithms. But here, there's some rules for these basic properties that we're about to look at. Okay, so basic rules. Okay. All right. So the first one is called, and sometimes your book will call, or some textbooks will call them laws of logarithm. So properties of logarithms, laws of logarithms, depends on your textbook. Okay, depends on the textbook. All right. So the first one is called the product rule. Okay, the first one's called the product rule. Product rule, for logarithm. All right. Now, before we look at the product rule, let's kind of remember something about the product rule for exponents. Product rule for exponents. So remember this right here, where we have b to the m times b to the n. So when you do this product rule for exponents, when you multiply like bases, what do you do with those exponents? You add it, right? So it'll be b to the m plus n. So the product rule is going to involve addition. Now there is a derivation. There is a proof on these these laws, these properties, why they look like that. But that's not going to be in this lesson. That's going to be something else. But you got to understand that the product rule is going to involve an addition. Okay, so here's what the product rule says. So here's the product rule. The log of a product, here's the product, the log of a product, m times n with base b, whatever your base may be, okay? All right, so remember, product rule for exponents, when you multiply like bases, you add exponents, right? Okay, so that's going to become, so I can write this, I can expand this, I'm using the word expand, I can expand this as the log of the first factor, base b, plus the log of the second factor, base b. Okay? So the log of a product is the sum of each log. Okay? So the log of a product is the sum of the logs of each factor. All right? So in words, the logarithm, I want you to remember this, the logarithm of a product, okay, no matter what your base is, as long as it's the logarithmic base, remember it cannot be negative, cannot be 1, is the sum of the logarithm of the factors. Okay, so I'm calling these factors. Remember, m times n, whatever this product is, that's a factor, that's a factor. So let's call them factors for right now. That's going to help you when we get into variable expressions. Okay? All right, so that's a product rule. Kind of made sense. When you multiply like bases, you add exponents. So the log of a product is the sum of each individual factor. But don't forget the base. Many students forget the base. You got to have a base listed here. If you don't have a base, remember that's understood to be 10, and that may not be a 10 right here. Okay? All right. Number 2 is called the quotient rule. Quotient rule for logarithms. All right. So let's kind of review something about the exponent rule then. So remember when you dealt with the properties for exponents in the previous course, you had b to the m divided by b to the n. And so when you divided like bases, what did you do with those exponents? You subtracted. So it'll be b to the m minus n. So that's the quotient rule for exponents right here. So you deal with quotient, remember division. Okay, divide like bases, subtract exponents. Okay, so the quotient rule for exponents is, for logarithms rather, is going to also involve a subtraction. So here's what it looks like. The log of m divided by n, base b, whatever the base may be, is equal to, now remember when we did this, the first thing listed here was the exponent of the numerator. Okay, so that was listed first, that's listed second. Same thing here. The numerator is listed first, the denominator is listed second. Because remember, subtraction is not commutative. The order in which you subtract does matter. So it does matter what's listed first. So this would become the log of m base b minus the log of n base b. So that's your quotient rule. Okay? That's a quotient rule. Okay, and then the next rule, so there are 3 of them. There's a product rule, quotient rule, and then the other one's called the power rule. Power rule. Okay? So power rule for logarithms. All right, so let's review this. Review. So let's talk about the power rule for exponents. So remember, this is review. So remember when we did the power rule for exponents, we had something like this, b to the m raised to the n power. So when you have a power raised to a power, you multiply. Okay, so b to the m times n. So we multiplied those powers, right? We multiplied the exponents. All right. So the power rule, when we look at it, is going to involve a multiplication. You're going to see what that means. All right. So remember the product rule, multiply like bases, we added exponents. So that's an addition. Quotient rule, when we divided like bases, we did subtraction. So just remember that's going to be subtraction. And then the power rule, when you have an exponent raised to an exponent, we multiply. So that's going to be a multiplication issue here. Okay? All right, so here's what it looks like. Here's what the power rule is going to look like. The log of m raised to a p power, okay? All right, regardless of what the base is going to equal, now here's how you write this. Now remember the derivation is in another lesson. It's not going to be part of this. We don't have time to talk about the proofs on how all these come to be. So basically what's going to happen is you're going to take your power, and remember you multiplied, right? So you're going to take your power and you're going to write as a multiplication. So instead of writing as an exponent, this becomes p times the log of m base b. So basically you took your power, your exponent, and you wrote as a product. See how we took the exponent right here and wrote as a product. So m times n. So p, you write as a product. So just always kind of remember what some students do is they do this. So they take this and they say, okay, I'm going to use this kind of arrow to imply multiplication. Okay? All right. Now let's look at some examples dealing with just those 3, and those are going to be some easy examples. And then in part 2, they become a little bit more complicated but doable as long as you know these properties. Okay? All right, so let's go to this one. So number one, let's suppose we want to use the product, use the product rule. So number one, use the product rule to expand the log expression. All right, so we're going to use the product rule to expand the log expression. So we use the word expand. So as we go through this, I'm going to explain what that means. And I kind of used, if you go back to this part of the video, I did mention the word expand. So notice I took this product, the log of this product, and I expanded. So this is expanding. So going from a 1 logarithm to 2 logarithms, that's expanding. Okay, that's expanding. See how I went from there's only 1 log, and then all of a sudden I have a sum of 2 logs, right? That's expanding. This is expanding. I went from 1 log to how many logs? 2. Subtraction. All right, that's expanding. And then this is expanding as well because even though you still have 1 log, you rewrote this as a product. So you kind of expanded this to a product. Okay, so you expanded this to an addition, you expanded this to a subtraction, and you expanded this to a product. Okay, all right, so that's what we mean by expanding. So let's look at part A. So in part A, let's suppose I want you to expand this. So let's say we had the log of 8 times 3 base 5. All right, so the log of 8 times 3 base 5. And all they want you to do is expand it. So don't write it's 24. Okay, that's not what they want you to do. They want you to use the product rule. So remember the product rule says I take the log of a product and I rise a sum, where the first factor is listed and the second factor is listed, right? Okay, so my first factor is 8, my second factor is 3, my base is 5. So that becomes the log of 8 base 5 plus the log of 3 base 5. And that's it. There's your answer. That's all they want you to do. So I expanded this. Okay, next one. B, let's suppose I had the log base 6 of 2x. Log base 6 of 2x. Okay, log base 6 of 2x. Okay, well, I can use the product rule again because here's my first factor, here's my second. So it becomes the log of 2 base 6 plus the log of x base 6. All right. Number 3, C rather. Let's suppose I had the log of 100. Log of 100 y. Log of 100 y. All right. Now notice this base is 5. This base is 6. What's this base? This base is 10. Okay. So that's going to become the log of 100 plus the log of y. Okay? All right, now here is where you have to think. Okay, so even though I expanded this, and even though I expanded this, something in here can be simplified further. See this right here? That base is 10, right? So I can write this, I can simplify this. So you need to evaluate whenever possible. Evaluate whenever possible. So in a previous lesson, you learned that this right here, the log of 100, 10 to what power is 100? So you got to think like that now. 10 to what power is 100? Can you do this very easily? Yeah, 10 squared is 100, so that's 2. So it becomes 2 plus, and there's no way you can simplify this because then you're saying 10 to what power is y? Well, I don't know. All right, so that'll be the log of y. So over here, you'd say 10 to what power is 2? Well, I don't know. That's not easy to do. And then that's a variable expression. So the point being this, usually whenever you have your base, whenever the argument's a whole number, a number, and your base, you always be well, it won't always be a whole number, but it could be a decimal. But if this is a whole number and this is a whole number, see if you can use things you've learned in the past without using a calculator. 6 to what power is 2? I don't know. That's hard. 3 5 rather to what power is 8? I don't know. I would need my calculator with that. I would need the base change formula, right? Okay. So, whenever possible, evaluate whenever possible without using a calculator. And it will say without using a calculator. Without using a calculator. And we're going to do more with this in part 2. So this will become more intense in part 2. Okay? Okay, now number 2. So that was a product rule. So you saw how it looks. So those are the easy kinds right now. We're just looking at the basic properties of these. The next part, the next lesson, these arguments become a little bit more involved. Okay? All right, number 2, so number 1 was the product rule. Number 2 is going to say use the quotient rule. Use the quotient rule to expand the log expression. All right, and this right here should have said use a product rule. All right, so part A. All right, part A, let's suppose we had this. Suppose we had the log of 8, log base 8 of, let's say, 21 divided by x. Log base 8 of 21 divided by x. Well, remember, that's a quotient, right? So whenever you look at quotient, you take subtraction. So that's going to be the log of 21 base 8 minus the log of x base 8. All right. Now, you see how this argument's a whole number? See if you can do this without using a calculator. So 8 to what power is 25? There isn't any nice one, right? So you're done. This is it. B, let's suppose you had this. Let's suppose you had the natural log of, let's say, e divided by 5. E divided by 5. All right, well, y'all agree that's going to be the natural log of e minus the natural log of 5, right? Okay. All right, now you got to remember this. What do you remember about this? What's the natural log of v? All right, good. The natural log of v is 1, right? Because remember, natural log of e means the same thing as log of e base e. And then in a previous lesson, you said e to what power is e? 1. So that's 1. So that's where this comes into play. So you see how you got to start thinking like this? And then here, you're going to say e to what power is 5? Well, I don't know. I would do my calculator to approximate. That's going to be an approximation. That's going to be an exact answer right here. If so that's 1. So it'll be 1 minus natural log of 5. Okay. See? What if I had this? Natural log of e to the 3rd power divided by x. Natural log of e to the 3rd power divided by x. Well, if I expand that, that's going to be the natural log of e to the 3rd minus the natural log of x, right? All right, so remember what to do with this, right? So remember, those are property. You can look at this. You can look at this and tell me what that's equal to. You have to go ahead and rewrite this whenever possible. So the natural log of e to the 3rd. Remember when we talked about the natural log of e to the b power? That's just b, right? That's just that exponent. So that was from a previous lesson. But if you want to, you can do this also. You can ask yourself, okay, I'm going to write this equal box. And so you're going to say, remember, this base right here is e. So e to the box equal e to the 3rd. So what should this box equal? Well, it should be 3. So that's 3 right here. So that's 3 minus natural log of x. Okay? All right, so that was the quotient rule. So that was just the basic properties. In the next part, these become a little bit more complicated. But you got to remember, you need to evaluate whenever possible. Okay? All right, number 3. So number 3, let's suppose I have this. Use the power rule. Use a power rule to expand the log expression. All right, so use a power rule to expand the log expression. Okay, letter A. I have the log of 6 to the fourth power base, let's say 7. All right, well, you know what the power rule says. The power rule says I take that exponent and I just write it as a product. So the answer is going to be 4 times the log of 6 base 7. And there's no way you can evaluate 7 to what power 6. That's not an easy thing. You would need your calculator for that one. That would be an approximation. Okay? What about if I had this? The log of, let's say, 6 to the third power base 6. All right, 6 to the third power base 6. Well, that kind of, if you think about it, that kind of takes us back to this, right? So see how remember there was a property we talked about before that said the log of b to the, let's say, the x power base b. So if these bases were the same, it's just the exponent, right? Same thing here. See how these bases are the same? So you notice it's going to be 3, but let's go ahead and use a power rule. So that says I can write this as 3 times the log of 6 base 6. And so I want you to think about this. See, I'm going to go ahead and rewrite this. 3 of log 6 base 6. What is the log of 6 base 6? 6 to what power 6? That's 1. So that becomes 3 times 1, which is 3. So that's going to be 3. All right, so you need to, whenever possible, you need to evaluate. Evaluate whenever possible. Okay? Evaluate whenever possible. Okay, letter C. Suppose I had the natural log of the square root of y. Natural log of the square root of y. All right, well, you got to remember something about square roots or cube roots. You got to remember something about radicals. So you got to recall this. Recall that if I have the a root of b to the c power, let's say, all right, I can always write this, and that was from a previous course, I can always write this as a rational exponent. I can write this as b to the c divided by a. So remember the exponent c is your numerator, the index is your denominator. So this right here means, first of all, I can write this as a natural log of y. See, that's y to the first, right? If there's no exponent listed, that's 1. So it'll be 1 divided by, what's the exponent? 2. So you got to remember that the square root of y means the same thing as y to the 1/2. Okay? Just like the cube root of y would be what? Y to what power? 1/3. The fourth root of y to the 5th would be what? Y to the 5th divided by 5 divided by 4. Okay? So that's just using the this rule from a previous course. And so now I can use a power rule. So what do I do with this 1/2? I write it in front as a product. So it becomes 1/2 times the natural log of y. Okay? D. All right, suppose I had this. All right, suppose I had the log of 6x to the 4th power. Log of 6x to the 4th power. Okay? All right, now we want to use the power rule. Now, all they ask you to do is use the power rule, okay? That's all they want you to do. Just use the power rule. So basically, I take this exponent and I put it out in front. So it'll be 4 times the log of 6x. Okay, now, remember all I did was use the power rule, right? That's all they wanted me to do. So according to the directions, I'm done. I'm done. Okay? So all they want you to do is use the power rule only. Use power rule only. Okay, now here's where we're getting to in part 2. So in part 2, I want you to start thinking about this. I still have the log of a product, don't I? So in part 2, you're going to expand this even further. So in part 2, this becomes, okay, listen carefully, this becomes, all right, so remember the log of a product? All right, so this you're getting a taste for part 2. So this becomes 4 times, all right, let's expand this. That's the log of 6 plus the log of x, right? Log of 6 plus the log of x. And then distributing, I get 4 log 6 plus 4 log x. Okay? And that's your answer there. All right, so 4 log 6 plus 4 log x, that would be part 2. So that's what we're getting at. So that's going to be what we're going to start looking at in part 2. All right, so this all we want to do in part 1 was to look at the base change formula and also to look at the basic laws of logarithms. And notice we just did some basic problems. So we talked about the product rule, which became an addition problem. We talked about the quotient rule, which involves subtraction. And then we talked about the power rule, which involved a product. And then we looked at very simple examples with those, just learning how to use those basic rules. Then we got to a problem where we're getting into what's going to happen in part 2. So all they wanted us to do in this problem here was use the power rule, which I did. Okay. And then we noticed that, hey, that's still a log of a product. Well, couldn't I use the product rule? Yes, you could. And that's part 2. Okay. All right. So that is the lesson for part 1.